So you are welcome to Trinity Mathematical Clinic. My name is Mega and I shall be your host in this particular video, and we shall be looking at still on integration, and today we're going to be looking at function of a linear function. And what do we mean by the integration of a function of a linear function? A function of a linear function is a function whose highest degree of the variable given is 1, or the power of the variable given is 1. So we are going to be looking at the integral of function of a linear function. Now, before we begin, we are going to draw a very simple analogy. Let us assume that, as usual, we are going to assume a function. We have that let y be equal to the integral of x raised to the power of 3 with respect to x. And I believe that you can actually integrate that because x there is just a simple guy, as easy as it is. But what if x decides to change its mind and say, no, I don't want to be x anymore. I want to be something even more. So in this case, we can simply replace x by a linear function or an expression such that we can say replacing x by 5x minus 4. What becomes of y? If we replace x by this given function, we are going to be having it to be given. We are going to have y to be given by y is equal to the integral of x being replaced by 5x minus 4. We have that to be given by 5x minus 4 raised to the power of 3 integrated with respect to x. So now in this case we are now having a function that contains a linear function which is raised to the power of 3. So the question is, how do we evaluate the integral of a function containing a linear function? So you've been able to understand the linear function in the given integral would help you to know how you can evaluate this now. So since this is 5x minus 4 is a linear function, what makes it a linear function? It is a linear function because if you look at 5x minus 4, the highest power of x here is just 1. That's why it is said to be a linear function. So in this case now, we are having 5x minus 4 being a linear function raised to the power of 3. To evaluate this, we carry out simple substitution by saying, hey, you linear function, come out. So when you bring out this linear function out, 5x minus 4, and say, let's u be equal to the linear function 5x minus 4, 5x minus 4. Then what happens to the original integral? The original integral becomes y is equal to the integral of 5x minus 4 is now replaced by u. So we have it to be u raised to the power of 3 with respect to x. So in this case, this helps us to be able to convert a simple linear function into a even more simple linear function so that we can be able to integrate them easily. So we are going to see how this is actually being done in this example. So coming back to this example, we have to evaluate y, which is the integral of 5x minus 4 raised to the power of 3. Now, how do we do that? For the first part of the question, we have y is equal to the integral of what? Of 5x minus 4. Look at 5x minus 4 does not have any power of 2. If it was having a power of 2 here, it would have been, a quadratic function. But in this case, it is a linear function. Why? Because the power of x here, the variable, is 1. So we are having here to be given by 5x minus 4 raised to the power of 3 to be integrated with respect to x. So to begin evaluating this integral, we can help ourselves by bringing out this linear function out of the integrand so that we have yet to be given by saying that let's u be equal to 5x minus 4. the linear function. So if u is equal to 5x minus 4, then y is going to become, y will be equal to the integral of u, since 5x minus 4, as assume a new variable which is u, 5x minus 4 replaced by u, and this is to the power of 3 with respect to x. So this is where we are now. Now, if you look at this integral, there is something really, really fishy about this integral, and that is what? If you look at this, you're having u and you're having another variable x. This statement means that integrate u with respect to x. That is what it means. Integrate u to the power of 3 with respect to x. So there is a conflict in the language of these particular statements. It says that we are integrating u raised to the power of 3 with respect to x. Since there is a conflict between these two variables, what do we have to do? We have to go back to our original assumption where we said let u be equal to 5x minus 4, so that we can be able to know the value of the x, then bring it back. So what we are going to do right now is I will come to this and we differentiate u with respect to x so that we can know what x is and carry out necessary substitution. So this is it now. Now, since we know that u is equal to 5x minus 4, we can help ourselves to differentiate this. When we differentiate this, we have that du with respect to du dx is equal to 5x. If we differentiate 5x, it is 5. It is 5. And if we differentiate minus 4, that is going to give us 0. So in this now, what is the purpose of carrying out this differentiation in u with respect to x? So that we can find the value of the x. So when we cross multiply here, we have that du is equal to 5 dx. And if you make the x the subject of the formula, we have here that the x is equal to du all over 5. So right now, we have expressed this dx in terms of a variable in u, so that the integral will be conformal to all variables in terms of u. So with this, we can substitute. So when we substituting into this given expression, we have that if y is equal to the integral of u to the power of 3 with respect to x, u to the power of 3 with respect to x, this is now going to be equal to the integral of u to the power of 3, where the x has a value in terms of u to be given as du over 5. So we substitute. So in this now, we have this to be given by the integral of this time this all over this is going to give us u raised to the power of 3 all over 5 du. Now in this, we have this to be given by, so the question now is, if you look at this now, this integral is now in a state of uniformity. Why? Because we are now integrating this function in u with respect to u, not this function in u with respect to a different variable. So we just cannot do that. So in this case now, how do we integrate this now? We are integrating this. To integrate this, we apply the rule, increase the power by 1 and divide by the new power. So we have here to be given by u raised to the power of 3 plus 1 all over divided by 3 plus 1. But if you look at the denominator here, there is an existing 5 here. So we just simply multiply by the new power 3 plus 1, 5 times open bracket 3 plus 1 plus the constant of integration, to show that we are working with an indefinite integral. So in this, we have this to be given by, is going to be equal to u raised to the power of 4 all over 5 times 3 plus 1. That is going to give us 20. So we have that to be given by 20 plus c. So it means that the value of this of y is equal to u raised to the power of 4 all over 20 plus c. But from the beginning, y was expressed in terms of x and not in terms of u. So we are going to carry out a resubstitution so that u is now expressed in terms of its original function. So we have this that therefore y is equal to, open bracket, 5x minus 4 raised to the power of 4 all over 20 plus c. So this is just how we can actually apply the integral of a function of a linear function. So you being able to identify the linear function in the given integral will help you know how to solve it. Now let's look at this particular question. We have b. We have the y. For the second question, y is equal to the integral of the exponential of 5x plus 2 with respect to x. So my question is, do you know the linear function there? Yes, the linear function here in this case is that particular function such that the variable there of that function, the highest variable there, is 1. So it means that our linear function is 5x plus 2. So in this case, we can go on to say that let u be equal to 5x plus 2. Now, take note that in this particular integral, this is the integral of the exponential of 5x plus 2 with respect to x. Take note that this integral could have actually been, this exponential could have just been the exponential of x raised to the power, the exponential of x with respect to x. So the integrating e raised to the power of x with respect to x. So this x could have just been just x. But x said, no, I want to be something more than just x. I could be more. That's why it is now 5x plus 2. So the new expression of x, which is this, the linear function, we can isolate it out and give it a new variable. So what do we do now? This implies that the variable y is equal to the integral of the exponential of 5x plus 2, as assume a new variable which is u with respect to x. So this is where we are now. If you look at this, there is still a conflict. You have this expression, this function to be integrated with respect to another variable that it does not have. How can you integrate a function with respect to what it does not have? You cannot give what you don't have. So what do? We have to go back to where we can find x and say, x, where are you? X says, I am here, but I am now in a new form, in the form of u. So what do? We are going to differentiate u with respect to x. So we can go on to say, but u itself is given by 5x plus 2. So when we differentiate this, u with respect to x, we have du over dx is equal to, differentiating 5x is going to give us 5, plus differentiating constants is going to give us 0, plus that is going to give us 5. So in this case now, we can go on to simplify our work. We can simplify this work, and this is going to be given by, we have here to be given by du is equal to 5 dx when you cross multiply, so that when you get what the x is, what the x stands for in this case, by change of subject formula, we have that the x is equal to du all over 5. So what does it mean? It means that the x now has a proper value so that it can be conformal to what we have here, which is e raised to the power of u. So in that case, we can make appropriate substitution by saying that then we have that our y is equal to the integral of the exponential u with respect to x. And this is also the same thing as the integral of exponential u times the x has a value, and that value is du over 5. So we have it to be du all over 5. So that this can be rewritten as the integral of this times this is going to give us the exponential of u all over 5 du. How do we integrate this now? Take note that this denominator 5 is a constant. We can actually get it out of the integral so that we have this to be equal to 1. Why 1? Because the coefficient of this fraction, the numerator of this fraction is 1. So we have it to be 1 all over 5. So we have this to be 5 of the integral of exponential u with respect to u. So this is going to be given by 1 all over 5 of the integral of an exponential function is going to give us an exponential function if with respect to u, with respect to that variable. If there is really no coefficient attached to the given variable here. So since there is no coefficient attached to u here, if you integrate an exponential function or you differentiate an exponential function, it is still going to give you that exponential function. It is more or less like the Nigerian system. The more governments you elect into the position, it really gives you the same government, so nothing really changed. It's possibly even become worse. So in this case here, the integral of exponential u is going to give us exponential u. So since we are done with that, now we also have to introduce a constant of integration. Normally, you can leave your answer like this, but it is going to be a problem. Why? Because the original function was given in terms of x and not in terms of u. So you cannot leave your answer like this. So what do? We have to express u in terms of its original function so that we can satisfy the condition for that given result of y. So we have that to be, therefore, y is equal to 1 all over 5 exponential u in its actual expression is given by 5x plus 2 plus c. So this is the answer to that. So thank you. So the next you're going to be having your own exercise to work with, and endeavor to please like the video and drop your comments in order for us to improve better on how we can serve you. So stay tuned and God bless you. Actually try out this question and also engage with us your answers in the comment section, and we promise to actually return replies to you. So please do well to solve these and also get back to us, and we'll also get back to each and every one of you.